get started here. Alright, for those of you who don't know, my name is Dan from Dan's Test Prep. You can check me out here at explore.danstestprep.com for all my social media, SAT newsletter, and just other helpful resources for SAT and ACT. So, the way that this session is going to work, we're going to start with some warm-up SAT problems. Then we'll go into some harder ACT problems and AMC competition problems. Then we'll do some community submitted questions. So if you guys have questions that are related to SAT and ACT, you could submit those to me during the session and I'll answer those live. Let's go ahead and get started. Our first set of questions here. I think it'll be real easy for some of you, or for most of you. We're going to be doing just a couple of warm-ups. So the first one we have here is, what is a solution to the given equation where x squared over 25 equals 36? I think some of you guys should be able to solve this right away, and you can use a calculator since this is digital SAT. But quite simply, we could do, or we could rewrite this as x squared is equal to 36 times 25, which should be 900. X squared equals 900. So if we want to get the solution for x, we would just take the square root, right? Square root is going to be, take square root here, x is equal to 30. And that's going to be exactly answer choice B. Yeah, let me post some of the questions here as well. So we've got number 7, for those of you guys who can't see. Number 7, Nasser bought 9 storage bins that were each the same price. He used a coupon for $63 off the entire purchase. The cost for the entire purchase after using the coupon was $27. What is the original price for one storage bin? I mean, not too bad, right? We know we can find the original price using the discounted price plus the amount on the coupon. So that's going to be, let me write it like this. Original price is 27 plus 63. That's going to be exactly $90. And when we take $90 divided by 9 storage bins, 9 bins, we're going to get it's $10 for one storage bin. Yep, Oliver's got it. Let's take a look at number 17 next. I like this one. For a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must the length change to maintain this ratio? Well, 35 to 10, length to width of 35 to 10 means that length is equal to 3.5 times larger than the width. 3.5 W. So if we get a width equal to 7 larger units, 7 more units, the width is going to be now 17. Length is going to be 3.5 times 17, which is 59.5. And of course, since we're looking at the length change, the change in this variable L is going to be the new value minus the original value. And that's going to give us 24.5. So of course, the length should increase by 24.5 units. We could have also just done 7, that increase of 7, times 3.5 to get that increase in length should be 24.5. Yep, you guys saying B, that's correct. Our last little warm-up problem here. paste it in for you guys. Square P has a side length of x inches. Square Q has a perimeter that is 176 inches greater than the perimeter of square P. The function f gives the area of square Q. Square Q is the greater one, right? Which of the following defines f? Okay, so I see this 176 in square Q, right? The perimeter is 176 inches greater. But if it's a square, that 176 inches is going to be distributed equally across all four sides. So if the original square had a side length of x, which is what the problem tells us, the new square, this perimeter of 4x, the new square would not have x plus 176. It's actually going to be x plus 44, because that would give us the perimeter of 4x plus 176. When we add up 44 plus 44 on each side. I see some people already get an A, which is good because that is the right answer for this one. The area of Q is going to be x plus 44 squared. Yeah, they might try to trick you with that 176, but the 176 is the total addition to the perimeter, so 44 on each side. I see we got a little question submitted here, so I'm gonna add that into the whiteboard. Yeah, we can even go over this one right now since it looks like a SAT question. We'll continue on our SAT grind. All right, who submitted this one? Hiram. All right, I think I recognize this from one of the practice tests, one of the paper ones. So, all right, the system of equations above has solution x comma y. What is the value of x? Well, we have this definition that y equals 2x. So I think we can really easily just substitute that in there. 1/2 2x plus y, the definition of y in terms of x is just y equals 2x. So you'll notice I substitute in for y right here. And that equals 21 over 2. When I combine the like terms, right, 1/2 times 4x equals 21 over 2, we can multiply by 2 on both sides here to get 4x equals 21. And then divide by 4 to get x equals 21 over 4. So what do we got? Oliver got that right. Yeah, another warm up. Sweet. I'm going to move on to some of the ACT problems. These should be a little bit harder, but I know for some of you guys, you're just superstars at this. So let me walk you guys through this. Number 52 here says the function f of x equals x cubed is defined for all real numbers x. Which of the following expressions represents f inverse of x? The -1 is not an exponent, but that's the inverse function of f. So the inverse function is just the function. I guess there's many ways you can define it. One way is that when you compose your function with the inverse function, you're just left with, what is it? 1 or x. Let's actually try that out. Figure that definition after we do the main method I use for solving, which is if we have an equation like y equals x cubed, what you can do to find the inverse function is usually a real easy way is to flip the variables, flip the positions of the variables. So instead here you could get like x equals y cubed. And then you solve back for y. So of course if I solve for y here, I'm going to take the cube root of both sides. Cube root of x equals to y. And that's, once you've solved for y, that's exactly your inverse function. F inverse of x is going to be the cube root of x. So of course that's going to be answer choice F. And now we can test that property I was talking about. F of F inverse of x is going to be the cube root of x cubed, which is just going to be x. So composing the two functions should give you back x. Yeah, let me copy this one down here. We'll do it after our ACT problems. You guys can keep the questions coming. 57 here is an interesting one. If t is any real number, which of the following statements must be true? Any real number. It has to be true for all real numbers. What do you guys think? Well, I know that negative t less than 0 is actually false. I mean, it's true for some cases, but not going to work in the case of, for example, t equals negative 2. Then negative t equals 2, which is not less than 0. If you can find a contradiction, any real number that contradicts this statement, you know that it's false. Negative t is less than t. Again, that's also false, right? We could have t equals negative 2, and then negative of t would be equal to 2, which is not going to be less than negative 2. It's going to be greater. Negative t equals t. That's completely false, and except in the case of t equal to 0. D. Negative t is less than or equal to the absolute value of t. That one seems like a good candidate. E. Negative t squared is equal to, or negative t whole thing squared is equal to negative t squared. That's false because this will turn into negative 1 squared times t squared, which will turn positive. So it becomes t squared, which does not equal to the right-hand side of negative t squared. So of course the only true one is going to be answer choice D. And that's because the absolute value turns everything positive. I actually just wrote my newsletter on this like a couple days ago about absolute value equations. Did it the wrong way? Uh, Here after these ACT problems, I'll reshare my screen for you guys, for those of you who can't see it. Alright, but for now I'll paste in number 59. Sessions will also be recorded and posted. Maybe you guys are watching this from YouTube right now, actually. Number 59 says, for real numbers a and b on the number line below, where a is less than b, which of the following values is a possible value for b? That's real interesting, right? The number line goes from smallest here to largest here. So how is it possible that the square root of something is larger than the original number? I see we already got an answer. That's the correct answer. But what about you other guys? What are you thinking here? Well, one thing I know for sure is we can't have negative numbers because the square root of something cannot be negative, and we cannot plug anything negative into the square root. 0, well, we have this strict inequality here. It's not less than or equals to, so it couldn't be 0 because that would make a equal to b. They'd, you know, or, oh wait, no. That would just not work because then a would have to be negative, and of course, we can't take a square root of a negative number and make it positive. B is 3/7. You know, this could work. This could work. Let's look through the other options. 1, b equals 1, b equals 9/4. The way we can differentiate these last few answers is we know that A has to be between 0 and 1. And how do we know that? Well, you notice how when we square rooted a number, it got larger. The only time that ever happens is when A is between 0 and 1. So something like square root of 0.25 is actually equal to 0.5. Maybe a little bit counterintuitive, but that's how it works, and you can try it out. So I know that this b value would also have to be somewhere within the range of 0 to 1. And actually with this example, if we chose a equal to 0.25, square root of a would be 0.5, 3/7 would fit right in between those two numbers. It'd definitely be a possible value. So we're going to go with 3/7 for b here. Of course, we need something less than 1, so those ones would not work. Yep, whoever got C, that is correct. And what do we got here? Last ACT problem. Feel free to submit your SAT questions in the meantime. Alright, 60. For all positive values of x, which of the following expressions is equivalent to 2 cube root of 2x times the cube root of x? All the answer choices look like they're under a cube root, which gives me a clue we want to put everything into the cube root, even this 2. So the first thing I can do is just combine, when I multiply things of the same root, we could just combine them. So under the cube root, I'll have 2x times x instead of keeping these in separate cube roots. So it's 2 cube root of 2x squared. And then what can we do with the 2 here? What can we do with this 2? Well, 2 is just the same thing as 2, 2 is the same thing as 8, or cube root of 8. So I'm going to write 2 as the cube root of 8 to make it match the cube root format that we have here. And again, using that multiplication rule where we can multiply different cube roots under the same root, we're going to get cube root of 2 times 8 is going to be 16, and then we just have that x squared. So that's exactly matching with answer choice K. That is correct. Let me take a second, try resharing this for you guys who can't see the stream. Hopefully that's better. All right. I'm going to go through these questions you guys have submitted. I got a lot of submissions here. Let me go over this next one here. Function f is defined by f of x is equal to 5x plus 8. For what value of x does f of x equal 58? Well, f of x equal to 58, I'm going to substitute that right here. 58 is equal to 5x plus 8. So we subtract 8 on both sides. That we get 50 is equal to 5x. And I think you guys see where I'm going from here. We divide both sides by 5. And we're left with x is equal to 10, which is answer choice A. That one makes sense? Yeah. I have a couple of other questions I saw someone submitted to me, so let me pick 2 of these that I find most interesting. Or I might only have space for one more here, actually. Let me do this one right here. going to paste that into our whiteboard. And if we have time at the end, we'll come back to some more of the community questions. What have we got here? Okay. Surface area of the cube is 6 times a over 4 squared, where a is a positive constant. Which of the following gives the perimeter of one face of the cube? It's not too bad. Surface area, I know surface area is equal to 6 times the side length squared, right? Because a cube has 6 equal sides, 6 equal faces, I should say. So if we have 6, if the surface area is 6 times a over 4 squared, and the formula is 6 times the number of the side length squared, we can just match different parts of this equation, or just divide both sides by 6 to get a over 4 is equal to s. Right, I kind of just skipped a step of square rooting everything here, but a over 4 is equal to s. That's the side length of the cube. Perimeter of the one face of the cube, of course, is a square. And the perimeter of a square is just 4 times the side length. So the perimeter is 4 times the side length, which we just solved for as a over 4, making your final answer B. SAT problem, nice. It's kind of small though. Okay. If we have some time at the end, I'm going to do some more SAT problems, like this one. But for now, we have some AMC problems, which I'm sure some of you guys are excited for. Some of these are really challenging, actually. This one took me a while. It says the sum of two natural numbers is 17,402. One of the two numbers is divisible by 10. If the units digit of that number is erased, the other number is obtained. What is the difference of these two numbers? The scenario we kind of have here is like we have a number like A, B, C, D, and it ends in a 0 because it's divisible by 10. If we erase that units digit, then we get the other number, A, B, C, D, just A, B, C, D. It was divided by 10. The sum A, B, C, D, 0 plus A, B, C, D equals to 17,402. Kind of just like representing this number with random digits that we don't know. So one thing to note here, let's call this smaller number as x instead of ABCD. It's just a lot easier. X, smaller number. The larger number here that we obtained the smaller number from by dividing by 10, that just means that the larger number is 10 times x, right? Larger number is just 10x. And we have the information about the sum, right? The sum x of the smaller number and the larger number, x plus 10x, is 17,402. Or simply put, 11x equals 17,402. Everyone following so far? I hope. So how do we get x? Well, some simple algebra here. We divide everything by 11. And I'm not sure if you actually get a calculator on these. So, let's just be safe and do it the long division way. 17,402 divided by 11, that's going to be a 1 there, minus 11, 6. Who still remembers how to do long division, by the way? Little known skill, I think. 55, get 9 here, 90, 11 goes into 98 times, well, minus 88. That leaves us with 2, and that goes down there to 22. So x is equal to 1582. Yeah, you guys better touch on your long division skills. X is equal to 1582. But that's not what we're asked to find. We're asked to find the difference of the two numbers, as in the larger number minus a smaller number. So the difference, which I'm going to do in green here, the difference is going to be the larger number. Let me do it like this. Larger minus the smaller number. Or that's 10x minus x. That's just 9x. And if we take 1582 times 9, love doing some math out by hand. We're going to get 8 here, and that's a 3, carry the 7 to get 45 plus 7 is 52, carry the 5. I definitely did not do that correctly. So let's go back and do that a little bit slower. 1582 times 9, that'll give us an 8 here, we'll carry the 1. 9 times 8 is 72, it gives us a 3 here, carry the 7. 5 times 9 is 45, plus 7 is 52, carry the 5, and then 9 times 1 is 9, plus 5 gives us 14. So 14,238, which is exactly matching with answer choice D. Yeah, long division is good. Good to know. You can also do polynomials with it. Cut out there for a little bit. Anyways, pasted the next problem in the chat. Looks interesting. I think this one could be like a little warm-up problem as well, or maybe systems of equations problem. Portia's high school has 3 times as many students as Lara's high school. Let me write that down. Portia's high school has 3 times as many as Lara's. The two high schools have a total of 2,600 students. In other words, P plus L equals 2,600. And how many students does Portia's high school have? Well, if I substitute this definition in here, the equations that I just wrote down, we're going to get 3L plus L is equal to 2,600. See how fast you guys can solve this one. Because we're going to get 4L equals 2,600, and we divide by 4 to get L equals 650. L equals 650 is, of course, not the right answer, because we're asking for Portia's high school. So P equals 3L equals 3 times 650 equals to 1950, which, of course, is the correct answer. It's going to be C. Yeah, whoever put B, close. But, you know, that's how they trick you. It's going to be C for this one. What have we got next here? Chantal and Jean start hiking from a trailhead towards a fire tower. Jean's wearing a heavy backpack and walks slower. Chantal starts walking at 4 miles per hour. Halfway to the tower, the trail becomes really steep, and Chantal slows down to 2 miles per hour. After reaching the tower, she immediately turns around and descends the steep part of the trail at 3 miles per hour. She meets Jean at the halfway point. What was Jean's average speed in miles per hour until they meet? It's an interesting one. Average speed. So there's an interesting little equation we can use here that's most helpful for us. The equation is that the rate of travel is equal to distance spent over time. And you can rewrite that in many different ways. You could do rate equals distance over time. You could do, in another color, of course, distance is equal to rate times time. You could do, of course, you need a third color to say time is equal to distance over the rate. What I'm going to do is put it in terms of this equation first. So the time they traveled was equal to distance over the rate. The distance, let's just call that d. Let's call the distance is d. That's an unknown. We have a couple unknowns here. For the first part of the trip, Chantal was going distance d at a rate of 4 miles per hour. Uh, then she was covering the distance at a rate of 3 miles per hour. Then a distance at a rate of 2 miles per hour. Or actually, these should be flipped. It was 2 and then 3. But nonetheless, this gives us the total time of travel in terms of the distance. And you'll see why I did this in a second here. Once we get the time in terms of the distance, we can then get the average speed or the rate here using that information. Because although we don't know the distance, we've written our time traveled in terms of the distance, which means that the d's should cancel out. Let's just verify that that's going to work. Time is equal to, let's get a common denominator here. It looks like the least common denominator would be 12. So I'm going to say this is 3d over 12. This is 6d over 12. And then this one is 4d over 12, which means that these add up to 13d over 12. And of course now we take the rate. The rate of travel was the distance they covered divided by the time taken. Now you can see when I substitute the time in terms of distance, these two distance cancel out. So the rate of travel was just 1 divided by 13 over 12. It's the same thing as 12 over 13 miles per hour. So that's going to be which answer choice? Answer choice A. Yeah, no messages for that one. Thanks. Seems like a tricky one. Community problem? Let me see, what time is it? Yeah, send them in. I'm gonna do this one real quick, and then we'll go to some more community submitted questions. This one's a fun one. Paste in the chat for you guys. Alright, and then we'll do some more problems. Tom is a collection of 13 snakes, 4 of which are purple and 5 of which are happy. He observes that all of his happy snakes can add, none of his purple snakes can subtract, and all of his snakes that can't subtract also can't add. Which of these conclusions can be drawn about Tom's snakes? Purple snakes can add. Purple snakes are happy. Snakes that can add are purple. Happy snakes are not purple. Happy snakes can't subtract. That's a lot of logic right there. So let's break it down. First off, all of his happy snakes can add. What I'm going to assume from that is that if you are happy, happy snake, then you can add. What else have we got here? None of his purple snakes can subtract. So if purple, then you can't subtract. And the last thing, all of his snakes that can't subtract also can't add. So if you can't subtract, then you also can't add. And actually from those last two we can draw another conclusion by combining these statements, which is that if you are purple, if you're a purple snake, then you can't add. Right? If you're purple, you can't subtract, but also if you can't subtract, then you can't add. So if you're a purple snake, you can't add. It just logically follows. The purple snakes can add. Well, that just directly contradicts what we just found. Purple snakes are happy. Don't think so. Snakes that can add are purple. No, we just found that if you're purple, you can't add. Happy snakes are not purple. Maybe. Happy snakes can't subtract. Not really anything that points towards that. Purple snakes are happy. Actually, these two are kind of like opposites of each other. Either purple snakes are happy or happy snakes are not purple. What I notice here with our purple snake, there's our snake. If you are happy, then you can add. If you are purple, then you can't add. Let me rewrite that down here. If you're happy, then you can add. These two directly contradict each other. You cannot be purple and happy at the same time. So what I'm going to do is cross out answer choice B, and I'm going to say, yeah, if you're a happy snake, you can obviously add. Therefore, you're not purple, because if you're purple, you can't add. That would cause a contradiction. Yeah, answer choice D. Exactly. Okay, I see we got some more problems here. Happy snakes. Why is E not correct? Happy snakes can't subtract. There's nothing that indicates that happy snakes can't subtract. I mean, they very well could subtract. And if the happy snakes could not subtract, then they also could not add, which would also be another contradiction. I see we got another problem here. So let me do a few more since we have some extra time here. We'll paste them all underneath. Actually, I had one in the queue already, so let's take a look at this one. Ooh. I think I've solved this one before. This looks like an old one. Oh, I know where I've seen this. Okay, let me paste it in the chat for you guys so you know which one we're on. Yeah, I think I saw this in like a Mind Your Decisions video. It was a fun one. Let's go through it. In the figure above, arc SBT is 1/4 of a circle with center R and radius 6. So that's SBT. If the length plus the width of rectangle ABCR, this one, is 8, then the perimeter of the shaded region is what? Actually, I don't remember how I solved this one before, so we're kind of approaching it from a clean slate. What I might do is just redraw the figure a little bit here, because it's kind of messy here, and I want to be able to label stuff. So got C, got A. I'm gonna call this, so this portion is 6. I want to call this little portion X, this tiny portion up here that's like between that where the triangle intersects the side and the top of that semicircle. Let me draw that right there. And then I call this little portion Y down here between C and T. Okay, so the perimeter of the shaded region is going to be what? Quite simply, that's equal to length AC plus CT plus side length SA plus arc SBT. There's 4 sides, 1, 2, 3, 4, that make up the perimeter of the shaded region. So let's see, this side length is also 6. Arc length SBT is going to be pretty simple to fill out. That's going to be 1/4 of a circle circumference, 1/4 of 2 pi times r, which is 6. It's going to be 3 pi. So probably going to rule out anything that has a 6 pi in it. What else have we got? What else have we got here? We've got this one is equal to x, this one's equal to y. That's interesting. Well, one piece of information that I haven't used yet is that the length plus the width of rectangle is 8. Of course, the length and the width are going to be this RC and AR. Length plus width equals to 8 tells us 6 minus x plus 6 minus y equals to 8. That tells us that 12 minus x minus y equals 8, which means I'm going to move the x and y onto the other side, and I'm going to subtract the 8 to get 4 equals x plus y. That's useful to us because remember CT and SA are just simply x and y. This is x plus y, these two terms. That becomes 4. So we have the 3 pi, we have the 4. Last thing is to find AC, which from the Pythagorean theorem, I think I'm just going to use the Pythagorean theorem to get AC. That would tell us that AC is 6 minus x squared plus 6 minus y squared, square rooted. That's the square root of, no, maybe there's a better way to do this. Maybe an easier way. Let's see. Diagonal there. Oh, that's just 6, right? The radius from here to here, it's also 6. So why don't we just set that equal to the radius, which is 6. So in total, when we're adding everything together, let's put this together with this together with this. Final is 6 plus 4 plus 3 pi, which is equal to 10 plus 3 pi, which is answer choice B. I can't believe they would put that on the SAT. Seems pretty difficult to me as well. Alright, what do we got next? I have maybe like spots for this question plus 2 more. So, okay. Okay, this is a 2-part question. We'll do that. Oh, this is a 4-part question. Dang. Okay, I don't think it should be too hard. It's just function operations. Part A, f plus g of x is the same thing, I believe, as just notation for f of x plus g of x, if I'm reading that correctly, which is just x plus 3 plus x minus 3, which is just 2x. Part B, f minus g is just f of x minus g of x, which is equal to x plus 3 minus x minus 3. That's 3 minus negative 3. That's just equal to 6. Good so far? Hardest SAT problem. Yeah. Last one. FG x is f of x times g of x. That's x plus 3 times x minus 3, which is reverse of the difference of squares. That's x squared minus 9. And then d, f of x divided by g of x. is x plus 3 over x minus 3. Can that be simplified anymore? I bet it can. And a domain is all numbers except for negative 3. Domain is x does not equal to positive 3, because that would make that function undefined. We'll just keep it in that form. What we got next? I know someone submitted a couple more problems, so let me pick one of those. One of these was nice. It's the circles question. We just did the hardest circles question, so this one should be a little bit easier. Equation above defines a circle. What are the coordinates of the center of the circle? Not too bad. We would just want to get this into x minus h squared plus y minus k squared equals r squared, kind of the standard form of circle equation, because right now it's in a general form. But we can try to speed run this, you know? You're going to have to complete the square. So, alright, maybe I won't go through it super fast, but I'll show you guys how to do this. Right, if we want to complete the square on x, we need to figure out what constant fits in here to make this perfect square factorable. Then we have the y squared plus 16y, and we need to figure out that constant, and then equals negative 20 plus, since I'm adding this constants to both sides, I want to make sure I actually want to make sure I add them to both sides to keep the balance of the equation. And the numbers that would fit in here is going to be take this, divide by 2, and square it. So plus 100 here, take this, divide by 2. Here, let me write the steps up here. Take coefficient on the x term, divide by 2, and square it. That's kind of the simple steps for completing the square. Yeah, I am. And I have a cheat sheet on my website for that as well, on the Dan's Test Prep blog. So adding that here, we get plus 64, and then we get negative 20 plus 100 plus 64. Now this one will easily factor to x plus 10, the whole thing squared. This one becomes y plus 8, y plus 8 squared. And then you could evaluate this as going to evaluate to 144, which is a radius of 12. But that's irrelevant because we're looking for the coordinates of the center. And the center, from this information right here, is very apparent. Who thinks it's at 10, 8? Say it in the chat. Alright, nobody fell for that. Yeah, since it's x minus h squared, it's going to be x minus negative 10 squared, actually is what this is. And this is y minus negative 8 squared equals 12 squared. That's the standard form, and that would make our center choice B, which is negative 10, negative 8. I think that one should be clear. Do probably one more problem here. Someone sent in. Alright, I'll do this one. Recognize a lot of these from the practice tests. Oh, okay, this one looks more interesting. Gonna do that one. Yeah, sure, I'll reshare my screen one more time for you guys. But the session is going to be recorded and posted as well, so keep an eye out for that. Alright, let me make that right over here. How many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? Whew. I remember when I first did this one, it was tough, but now these solution problems are no match. How many liters? That indicates to me an unknown. How many is unknown? So I'm going to call that as X. The concentration is 25%, which I'm going to put as 0.25. Then we have 3 liters of a 10% solution. That is a known quantity and a known concentration. That makes it a little bit easier for us. Finally, we want to obtain a 15% saline solution. Does anybody see the problem with this equation I just wrote down? Hmm, I don't see anything. Oh, maybe some typing. You guys see what I missed here? Because this is how a lot of people mess up, including myself in the first time around. But this one is missing, where we've always had a volume times a concentration. Volume times a concentration. Here we just have the concentration. Where's the volume? You know? So the correct equation would be, let me like mark that so we know it's incorrect. The correct equation would be x times 0.25 plus 3 times 0.10 is equal to 3 plus x, or x plus 3, doesn't matter, of times 0.15. 0.15x is close. We should be x plus 3 because now we're adding both of the x liters plus the 3 liters. So the total solution should be 15% concentrated, but it should be x plus 3 liters. I'm going to do everything in the same color now. It's going to be 0.25x plus 0.30 equals 0.15x plus 0.45. You can subtract on both sides the 0.15x. You can subtract the 0.30. You'll get 0.10x is equal to 0.15. That's the same thing as 10x is equal to 15, which is somehow the same thing, but just easier in my head to do because that gives us x equals 1.5. 1.5 liters. Yeah, no problem. That was good. A lot of good community questions. I had to make a new space on my board for that. I think I'm about done here, but you guys don't forget to check out my explore.dancetestprep.com page. I have my social medias on there if you want to check out TikTok, YouTube, whatever. I also have this page, join.dancetestprep.com, if you want to join the SAT newsletter where I send you a tip every week, help you with your prep. Otherwise, yeah, I'll see you guys next week. Good luck with your prep.